Hi, Michelle Glass here. Welcome back to another one of our Chapter 5 episodes. Our topic in this video is the cutaneous membrane, which is, of course, our fancy name for the skin, one of the organs that we are the most familiar with since we get to look at it every day. The cutaneous membrane is composed of both epithelial and connective tissues. It's described as thick and relatively waterproof. So we will see some water can cross the skin, but it's pretty limited. And then it's a dry membrane. The cutaneous membrane itself is made of two major layers. So you have the epidermis as the outermost layer. So when you're touching your skin, you're touching your epidermis. And then we have the dermis as the innermost layer. Now notice that the epidermis is composed of stratified squamous epithelium, while the dermis is composed of the connective tissue. That's the areolar and reticular tissues. Now notice these are the only two layers that technically make up the cutaneous membrane. Underneath the dermis, we have a layer which we can refer to either as the subcutaneous layer or the hypodermis. This is composed of adipose tissue. We will have a whole video just to discuss this particular layer. Remember, it's not really part of the cutaneous, it's not part of the cutaneous membrane. Therefore, it's not really part of the integumentary system, but it is important for the health of the body. So we do need to talk about it here in this chapter. Okay, looking at that outermost layer, the epidermis. The epidermis, again, is outermost. It is the protective physical barrier layer. It's composed of stratified squamous epithelium. It's helping to prevent water loss and also pathogen invasion. Notice that these cells of this stratified squamous epithelium will be called keratinocytes. So I introduced those to you in the previous video. These are going to be cells that make that special protein called keratin. Now, the epidermis layer is described as avascular. Avascular means without blood vessels. So what that does mean is as these cells are pushed further and further and further away from the dermis, we will see that they are dead cells, dying and dead cells as they get away from the dermis. You know, partly they're dying and dead because they're away from the blood supply. So they're not getting oxygen, they're not getting nutrients, and they're not getting waste removal. But the other reason actually has to do with the production of that keratin. So the keratin causes those cells to dry out and become hard, and so that's not conducive to a living cell. We will see that the epidermis itself, it's stratified squamous, so that means it's layered, and we'll see 4 to 5 different layers depending on the type of tissue, and we can refer to these layers as strata. Stratification, remember, is just talking about layers, so strata would be another name for layers. Okay, so when we are looking at the strata of the epidermis, we can start with the innermost layer, which is, so we're going inside to outside. So the innermost layer is the stratum basale, or you can call it the stratum germinativum. It's the innermost, it's sitting right on top of the dermis. Then we have the stratum spinosum, stratum granulosum, stratum lucidum. Now notice I've highlighted the stratum lucidum. That's because this layer is only found in what is called thick skin. Thick skin includes the palms of your hands and the soles of your feet. So all the other skin of your body would be considered a thin skin and would only have 4 layers. So stratum lucidum is only found in thick skin, which is the palms of your hand and the soles of your feet. And then the outermost layer, no matter if it's thin or thick skin, would be the stratum corneum. So when you're touching your skin, what layer are you touching? You're touching the stratum corneum. Okay. So let's take a look up close and personal at each of these layers. So notice here that I've drawn my dermis border to be orange. And notice that it's not a straight line, but you've got these waves. Now, the projections of the dermis are called dermal papillae. The AE ending is plural, so one is dermal papilla. The term papilla is talking like finger-like extensions. So notice that the dermis is sticking up in these projections, and in each of these papilla, each of these fingers, you're going to see nerves and you're going to see blood vessels. So the dermis is going to be supporting the epidermis. Now, sitting right on top of the dermis, you have your stratum basale. So this is the innermost layer. This consists of basal cells, which is how this layer is getting its name. The basal cells can also be called stem cells or germ cells. The signature of being a stem cell is that you are mitotically active. So remember, we've talked about mitosis in chapter 3, that's cell division to make more of the same. So we will see that these basal cells are constantly doing mitosis in order to make new keratinocytes that can go up through the layers of the epidermis, replacing, as you lose those top layers of cells of the stratum corneum, you're going to constantly have new cells coming in line to replace. So the stratum basale is named for these basal cells, these stem cells or germ cells, which are mitotically active. Okay, but that's not the only type of cell that we see in this layer. You also have Merkel cells. Merkel cells are going to be important. Sorry about that. Merkel cells are going to be important. Let me go ahead and turn that off. In detecting touch. Okay. So Merkel cells are going to be sensory receptor cells that are able to detect touch. And then you have the melanocyte. And the melanocyte, the CYTE ending tells us it's a cell. It's producing a pigment called melanin. And this pigment is, of course, one of the components that we see in skin color. So, of course, skin color has a genetic component as well as an environmental component. With more sun exposure, you're going to increase your amount of melanin production because this is how we protect our body from ultraviolet radiation. Now notice that these melanocytes are kind of crazy looking cells. They have these extensions and then they make these vesicles of melanin and they're transporting it through exocytosis up through the different layers. So we all have the same number of melanocytes, but we do see that the activity will differ, and that is, again, genetically and environmentally based. Okay, so sitting on top of the stratum basale, we have the stratum spinosum. So what we see is as those basal stem cells produce new keratinocytes, they're pushing those old ones up into the stratum spinosum. Now this layer is about 8 to 10 cells thick, depending on where we're located in the body. So obviously we have thinner cells on our lips and our cheeks than what you would expect to see on your elbow, right? Okay, now in addition to these keratinocytes that have been pushed up into the stratum spinosum, we also have dendritic cells. Dendritic cells are going to be able to protect us against pathogens and cancer cells that might be showing up in this layer. So if we've had pathogens that have penetrated our physical barrier of our epidermis and they've gotten here to the stratum spinosum, that's okay because we have these defense cells, these dendritic cells that can move around and phagocytize those possible pathogens. Now, I forgot to mention this on the previous screen, but notice we've talked about the dermal papilla sticking up. Let me click back. You have the epidermis kind of fitting into place in between. So where the dermis is sticking up, then the epidermis is going down in to fill those grooves, and we refer to that as the epidermal ridge. So notice that we have that the whole diagram of our cutaneous membrane, of our epidermis. Okay, now as those stratum spinosum cells get pushed up into the next layer, we see them becoming part of the stratum granulosum. And this is really where we start to see those cells really producing a lot of that keratin, really drying out, connecting together, further and further away from the blood supply. So cells in this layer are really beginning to dry out and die. So as we're getting into the stratum granulosum, we no longer have really actively dividing living cells. Next, we can see those cells getting pushed into the stratum lucidum, which remember is only found in thick skin, which is the palms of our hands and the soles of our feet. So if we're looking at other areas of the body, if we're looking at thin skin, this layer would not exist. Instead, you would go straight to the outermost layer, which is the stratum corneum. And so, of course, the stratum corneum is the outermost layer in each case. Now, again, I've drawn a few layers within each one of these layers, and that can vary. Again, whether you're looking at your lips or your cheeks or your elbow, or if you've developed calluses on part of your body because you're constantly exposing that skin to abrasion, then you would see that those layers would be a little bit thicker there than if you didn't have a lot of abrasion. So the cutaneous membrane, the layers present will be adjusted depending on the needs. So this is our epidermis. Sitting on top of the stratum corneum, you're going to see a lipid layer called sebum. Now, this is produced by a gland called the sebaceous gland, so we'll be talking about that in a later video. Now, this lipid layer on top is really helping to protect against water loss and water gain, because if you have a lipid layer, water is, of course, polar, and it doesn't easily cross through a non-polar layer of lipid layer. So this can stay for about 2 weeks and really helping to prevent those dried out stratum corneum cells from drying and cracking and compromising the integrity, as well as this sebum is important in lubricating those dried out keratinocytes, as well as providing kind of a little bit of water resistance over top of the cutaneous membrane. You are still losing some water across your skin all the time. About 500 milliliters of water is lost every day, but this is not like sweat moisture that you can detect. And so this is described as insensible evaporation, meaning it's this water loss that's happening outside of your sensory awareness. Now, remember, we've talked about the basal cells in that green layer, the stratum basale layer, which are doing mitosis, constantly making new keratinocytes. As you're making new, those old cells get pushed up through the layers so that from their new production in the stratum basale, they're pushed up through all of these layers, getting to that stratum corneum in about 7 to 10 days. And then they're just going to get lost just through regular wear and tear. Okay, so we've seen the epidermis having 4 or 5 layers, depending on whether we're looking at thick skin, or thin skin. And then we see that the epidermis is sitting on top of the dermis, which is composed of connective tissue. Now, there are 2 layers to the dermis, the papillary layer, which is going to be forming the papilla, hence the name, and the reticular layer. Now, the dermis is basically providing support to the epidermis. We will see vascularization in this layer, so that means blood vessels are here. We will see innervation in this layer, so this is where we see those nerves penetrating. And then we will see the support from the fibers of the reticular layer, the collagen and elastic fibers. The papillary layer is, remember, the topmost layer of the dermis. It's forming those dermal papillae. We will see not only nerves here and blood vessels, but also lymphatic vessels. So we can talk about it as being vascularized, highly vascularized, and also providing innervation, providing those nerves. And then the papillary layer is sitting on top of the reticular layer, which is going to have collagen protein fibers providing strength, as well as elastic or stretchy fibers, so that our skin is able to move as we move our body. So as we bend our different joints and flex our muscles and so forth, we're able to get that skin to stretch over top of our body, even during these different movements. Now, both those collagen and elastic fibers are going to be arranged in bundles that are parallel to each other, and this is important because they are resisting forces that are applied during normal movement. Now, this whole diagram of the arrangement of collagen and elastic fibers is called the tension lines of the skin, and they're arranged in such a way to be able to stretch and provide strength and all that with our normal body movements. Now, what is interesting is if you cut parallel to these tension lines, they're going to stay closed more easily and heal better. So you've noticed that some of your wounds heal faster than others, and this might explain why. Also, if you're a surgeon who's doing some strategic cuts, you would want to make sure that your cuts are parallel to the tension lines as opposed to perpendicular, so that those surgical incisions will heal and repair faster. Okay, that's it for now. Stay tuned for more.